In this current shunt resistance, the marking is 180 ampere oblique U. 180 ampere, that is amount of current. U, that is code for 75 millivolt. That means when 180 ampere will flow in this shunt resistance, that is the full scale current, that time it will provide 75 millivolt. This is the top limit. The current flows and voltage drop across that resistor will be taken out for some other measurements. If you want to know the value of this resistor, V over I. Voltage are 75 millivolt. 180 ampere, the amount of resistance is 0.000416, 416.66 microohms. When we say resistance, it is measured in ohms and power rating. Here, amount of current, we can also take V into I. We can calculate the power. V into I, P is equal to I square R. I received a comment from my viewer that why 75 millivolt? Why not 1 volt? This is question. Let's see it now. If we discuss this resistor value and this amount of current, I is 180 ampere by 417 microohm. 417 10 raised to power minus 6 multiplied by 180 ampere square, that is 13.5 watt. Most of the time in welding machines, the shunt resistance, current measurement resistance, is connected in negative line. This is negative out, positive out is taken out directly. This is negative out. Voltage across this resistor will be used for current measurements. This is low side. This line is connected to ground side of any current measurement circuit, and this is signal high. How much voltage will drop, that will be taken out. At 180 ampere current, if this resistor value is there, 0.075 volt, at full current 13.5 watt, that is large amount of power. If we say 1 volt, that time its resistor value will increase. Let's see that condition. R is equal to V over I. Let's suppose voltage are 1 volt. 180 ampere. 1 divided by 180, 0.005 or 5 milliohms. This is resistor value, and P is equal to I square R. If we use this resistor value, 5 milliohm, for this current, what will the power dissipation? Multiply by 180 square, 180 watt, 0.005 or 5 milliohms by 180 square, that means 180 watt. Just only changing this resistance from 416 microohms to 5 milliohm. This is the difference. If we will use 5 milliohm resistor instead of 416 microohm, to take 1 volt drop, Slightly increase in the resistance will cause to increase a huge amount of power dissipation. So that is reason in high current DC circuits, the possibly lowest value of the resistance is used to measure the current. I hope this video is informative. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.